Hello everybody and welcome to the Code Wrinkles channel for a new video that I hope will make you love programming and C# and .NET just a little bit more. Today we'll talk about a very interesting topic, although it seems a very simple one, and it is enums. Enums seem very simple to use, they are easy to understand, and also for every beginner developer they seem like a dream come true. However, by the time we write some production code, then we will see that there are certain problems or drawbacks with enums that make enums not that friendly anymore, I would say. And I have three major concerns about enums. First of all, behavior regarding certain enumerations tend to be scattered all around the code base. And from this it results a second concern, and when we make a change to an enum, then we have to go back to a lot of places in our codebase and adapt our code to the changes that we just made. And from this one, it results the third concern that I have, and it seems that enums don't follow the open-close principle. So they are not open for extensions, and well, if we do modification, well, then we have a lot of problems because we have to change a lot in our code. And right now we have on screen a demo code that is very simple to understand, but I guess that this is one type of code that we see a lot in the programs, in the applications that we are writing. And here, for instance, we have an employee type enum, and we have here a method that simply calculates salaries for different type of employees. And we see here this typical switch statement that we usually see when we work with enums. And what happens here is that, well, we calculate the salary for each type of employee differently, and we do this in our code base or directly in our switch statement. So if we run this application now, I guess that, well, everything seems to be fine. But here we already see another problem that I have with enums, and that they don't display very friendly strings. So if we want to get displayed this string also with spaces, then we would have to use some attributes to write some extensions for enums and so on. So it's very hard to get it's harder to get friendly strings printed out to the console when we use enums. So this example here seems very easy, and as said, I think that many of us, including me, have written code that looks like this. However, the big problem here is, for instance, if I go here to the enum type, and I will add just another enum, and in this case it would be a team lead. And right now, if I run the program, sorry, let's make also a console write line for this team lead. We just have to make some changes here. So here we just choose the new enumeration. Then we have to do the same thing also here. And right now we have added something here. But if we run this application right now, it will display something in the console, but it will be a 0. That's simply because in this method calculate salary, the default I put on to be salary equals 0. And of course salary is of type int, the default value is however 0, but I wanted to make it very explicit right here what happens. So this means that right now, in order to accommodate the change that I have done to this enum, I need to come back to this method and simply add a new case that would handle this type of scenario, or a new type or a new element in the enumeration. And imagine if I have a real production code and maybe I do different type of calculations or apply different type of business logic based on this enum. I would literally have to find any piece of code or each piece of code that contains a switch statement on this employee type enum. And if you have, I don't know, hundreds or thousands of different classes and folders and maybe projects that are referenced and so on, you would have to look in a lot of places. And the problem is that, okay, maybe you forget just one of the places. But in this case, if you forget, for instance, for how we calculate the salary, we just return 0, so it just returns a wrong result. It returns a value that doesn't make any sense for our application. But often in code, in the default, we put something like this. Throw new argument exception, And here maybe we say a message that employee type was not found. And the problem here, of course, in this case, we would have to delete this break. That's really not needed anymore. But the real problem in this case is that, of course, if I run the application, what happens is, well, I will get an error. Its employee type was not found, which is exactly what I specified here. And this is also a pattern that you will see in a lot of code bases, where in the default you just throw an exception that you will catch eventually, that will catch eventually somewhere else. But in order to not return wrong results or results that or values that are basically useless for the application or for the logic of the application, we just throw exception. And here you can imagine that the simple fact that I added a new enumeration, a new item in the enum, makes basically my program crash, which is a big problem. Because one little change, or literally very small change, could make an entire application break down. And this is surely not something that we would like to do. So in this case, we could maybe try to implement enumeration in a different way. And something that I came across, I would say fairly recently, although this topic or this concept is not really new. I read a blog post from Jimmy Bogart about custom enumeration classes that was written in 2008, so it's already 12 years. But I guess that this type of pattern of using enumeration classes, custom enumeration classes, might actually be helpful in a lot of scenarios where we use enum very heavily and also perform business logic or complex business logic based on what we have in an enumeration. So let's see how we can maybe implement that. First, I would like to create a new class. So let's add a new class here, and I will call this new class simply employee. Let's not do any typos. Employee type. And here in this class, let's make it public for now, and we'll see just a little bit later what else we can do with this class. But the whole concept about implementing a custom enumeration class is really not very complicated. Actually, there are very few things that we need to have a class that behaves actually like the enums, like the default enums that we have in C#. So the first thing that I will do here is let's make a private constructor. And we'll see just in a while why I want this constructor to be private. And in this constructor, I would take an int value and a string description. Okay, let's don't capitalize value here. And of course, what we would need are two properties, public int value, and we'll have a private setter, because we don't want anybody else except this class to be able to modify or to set the value for this property. And we have also public string description, and once again get, and we have a private setter. And what we do in the constructor is simply, of course, assign the values. So value is value and description is description. So that would be it if I don't have any typos. And this is exactly the basic concept that also default enums have in C#. Because behind the scenes, what you see here, just a simple enumeration. Behind this we have basically integers, and if we don't specify any integer, any custom integer, it will always start from 0, then this one would be 1, this one would be 2, and this one would be 3, and so on. So this is exactly what we try to do in our custom enum class. And the only thing that we still need to do here right now is to create some private fields, static, read only, and if would be of type employee type. And let's call the first one junior, and this would be equal new employee type. Sorry, and here let's pass in a value. Let's start also from 0, and add a value junior developer. And you already see that when we do these custom enum classes, it's very easy to actually get friendly display names or friendly descriptions of the enum. You just have to provide the string that you want in the format that you want, and that string will be then used. Then we have a static read-only. Let's make another employee type. Let's call that mid, and this would be a new employee type. And here we will use value, we will use 1, and we will use here mid-level developer. Hopefully there aren't typos here. And let's make also a third one, which would be again static read-only. It would be once again of type employee type, and this would be senior, and it would be new employee type. Here we'll take 2 as a value, we go in order. And here we say senior developer, and that's basically it for now. Although we'll come back to this class and we'll do some different changes here. Now what we can do here is go back to this program class, and we'll try to replace this employee type enum with our custom employee type enumeration class. And here what we would have to do in this case is simply have here employee type, and just like normal enums, sorry, we have a problem here, equals, I don't want to let me employ, okay, private static, let's also make this although no, I don't want to have this class static, but what we can see here is that okay, we have junior and we assign this value, so this should be they are private, sorry. I'm very accustomed for fields to make them private, but of course in this case we need them public. And also because these fields will be displayed publicly, I also choose to not follow the way that I usually name fields with underscore, but simply name them as properties. So then if we go back once again in program.cs, we have here once again employee type, and right now we can check here junior, and we see that okay, for this employee type junior, I want to calculate the salary. Now, of course, this method right now doesn't really work, and I have to refactor everything just a little bit more. And the biggest problem is that in this case, I won't be able to simply use this calculate salary method anymore, or at least not with a switch. But maybe we can try do something here. So we can have employee type as an incoming parameter, and let's delete everything right now, and let's try to re-implement this method a little bit differently. And here we will replace, because we won't be able to use switch statements anymore, because right now the way our custom enum type works, it's not okay, or it wouldn't work with switch statement. But we can say that if type equals employee type dot junior, in that case we can simply return, and let's make 30 and multiply this with 160, which would be with worked hours. We get this information here, and of course, yeah, we have to check for equality in this case. Now we can then simply go further and say that else if type equals employee type mid, then in this case what we can return, just as we had previously, we can return 50, multiply it by the worked hours, and that should be it. And another else if, here we check if the type equals employee type senior, And then we return, of course, what we want to calculate for senior, and it would be, in this case, let's make it 75, multiply that by worked hours, and that should be it. And then at the end we can simply return 0 if none of these are true. And now we can change this, and here what we want to do is we simply will have an employee type. Here it will be junior, and this would be like that. Then we would have to change also here employee type. Of course, we don't have this mid software developer, but we have mid. And when we calculate the salary, we will have to add the exact same thing. So we have an employee type, and it would be in this case mid, which is okay. Now, of course, I have this senior, and let's make it here employee type. Let's make it senior, and here, of course, we also have to change this and choose employee type senior. So on our class. For now, we don't have a team lead, so what we'll do here is right now we'll comment out this part, but we will come back to this just when we add a new part in our enumeration. And yeah, right now I guess we don't have any errors, so theoretically if I run the application, it should return the results which are correct, but we see that we display here the type as a string, which is not what we wanted, and we can easily fix this by going to our enum type, and what we will do is we'll simply override the toString method. Public override string to string, of course, and what we want here is to return the description. So yeah, that should be it. So right now, once again, we don't have any errors, and if we run this application again, we should also have the friendly names like we see here, without the need to work with extension methods on enums or with different attributes and different libraries that we may need to install to be able to work with friendly names for default enums. So we have right now the same behavior. We use right now our custom enum class, but actually the problem that we started with is still here, because in our code base right now, if we go to employee type and if we add a new type of employee like team leader, then we'll actually have the same problem that we had previously with the default enums. But here comes actually the power of custom enumeration classes, because as long or in the moment that you created a custom enumeration class, you can actually add behavior to that class, and you cannot add behavior to the default enums. And this is, from my point of view, a very, very important thing that we would need in programming in general in order to be able to really implement polymorphic behavior and thus making our code compliant with the solid principles, and more specifically with the open-close principle. So what this means for us in this case is that we can simply move this calculate salary method that we have here, we can move it and define it as behavior on the class itself. So in this case, we can go to employee type, and here we can say, for instance, public, it will return an int, and it is called calculate salary. Right now, for the beginning, we will take employee type as the type, and the worked hours of type int, of course, worked hours, just like we had previously. And actually what we can do right now is go back here in this calculate salary, and we just can use this code, reuse the code that we have here. So we go to employee type and just implement this code, which is or seems to be okay. Okay, and right now, okay, they say that that the name can be simplified, but I just wanted to make sure, or I want to have everything really explicit here. And then we can go back to our program class, and here we can change once again the way we calculate the salary. And instead of calculating the salary based on this calculate salary method that we have here, we moved this behavior on the enum itself. So this means that when we do the console write line, we don't just simply calculate salary, but we say, for instance, that on employee type junior calculate salary. And here we have then the employee type that we pass in, and then we have the number of worked hours that we pass in, and everything should be fine. Now then we have to do the same thing here. So here we could simply add employee type dot we are here for a mid, and here for the mid we want to calculate the salary, and we pass in the exact same values, which is okay. And then for this other one, employee type dot, here it would be the senior, for which we want to calculate the salary, and the method name stays the same. And right now we see that we have 0 references for this method calculate salary that we have in this program class, so we can simply remove it. And theoretically, if we run the application right now, I guess it should give the exact same result. So you see, what we did right now is a very important part or a very important thing from my point of view, because we just moved the behavior that we added to the initial enum in our program class. We have moved the behavior on the enumeration class itself, which is very important, because if we simply want to add a new type here, we can simply add it just here, public static read only employee type, and let's make it this team leader is new employee type. Let's give it a value of 3 and the description of team lead, and that's basically it. And if we go back to the program.cs class and we choose to uncomment this part of code, of course we also have to change this, because we want to use the employee type, and here I would use team leader, I guess. Yeah, correct. And here we do exactly the same thing on this team leader. So what it would be is that of course we can employee type dot team leader and calculate salary, and of course we have to pass in employee type, our custom class, and that's it. But of course team leader, it should be like that, and now we shouldn't have any error. So the idea is that in this case, when we need to make changes, we just need to make these changes here in this class, in our custom class. So no matter where in the code base our custom enumeration is used, the behavior for this class we simply modify or extend here. So this makes our class being opened to extensions. And of course this would also imply that we should add here just a new else if, and if type equals employee type team leader. In this case, I don't know, let's return, let's make it this time 80, multiply this by the worked hours, and that should be it right now. So we don't have any errors, it seems. So if we run the application, now we should also see the information about the team leader, and see that the team lead has right now also a value. And that's very cool actually, because right now we have moved all the behavior once again that was related to the enum, but that was not part of the enum itself, of the default of the default enum, because we cannot add behavior to default enums. So we move that behavior in our custom enumeration class, and this means that anytime we want to add something to extend the behavior of this custom enumeration class, we just have to make changes in this class, and our application won't break down. So this is very, very good. But once we already have this type of custom enumeration, there is one step further that we can actually go. And if we see here that we have still this concatenation of if and else if statements, and this is once again not really a best practice, I would say, because again, each time we want to add something new to our enumeration, even we are still in the same class, we also have to modify this method. But what we can do here is, as I said, go just a step further, and let's do this private class, and let's call this junior dev, and our class would inherit employee type. What this means is, of course, that we would need here a constructor, and in this constructor we would have to provide int value string description, and we have to pass this to the base class, and we pass the value and the description, and that should be it right now. So okay, right now what we can do here is make the behavior for the for the salary calculation be part of this junior dev class itself. So not of the employee type, but each class that would inherit this employee type can basically implement its own way of calculating salary, so its own behavior. So in this case, we can simply put here, let's make here this be public, and here let's make it int calculate salary, and as we are in this junior dev class, all the logic for how we calculate salary for a junior dev should be actually here, or this class should know exactly how to calculate salary only for a junior dev, not for a mid, not for a senior, only for the junior. And in this case, the only thing that we would need from outside would be probably an integer that would describe the worked hours. And then what we can do here is simply move this this return, we move it here, and that's it. So right now what we can do is simply we can get rid of this first if. Of course, then we have to get rid of this else, because in this case it's just an if. And to go just back a little bit here, instead of creating a new junior dev or a new employee type, what we will create is right now a junior dev instead. And it's actually exactly the same thing. From the outside, for the program class, it really doesn't care. It's really not important. This is the really nice thing about how polymorphism works in .NET in general, and in object-oriented programming. So here, no matter what changes we did in our custom enumeration class, where we consume it, we really don't need to be aware what happens under the hood. We know that we want an employee type junior, and we want to calculate the salary for it. So in this case, what we can do right now is, of course, go here for this calculation. In this case, we just don't need to provide the employee type anymore. We just need to provide the working hours. Now it says that employee type junior and calculate salary. Okay, it still wants us to. Let's make this virtual, of course, and let's override it. Private or public override int. But yeah, the problem in this case that we can't simply override because we still have to provide an employee type. So let's implement all the other types first, and then we'll see. Of course, then the type is not working. But let's also add other classes. Let's add a private class. It will be a mid dev. We add a constructor to it as we did previously. We take in an int that describes the value, and we take in a string that represents the description of the enum, and we simply pass it to the base, which will be we pass the value and the description. However, right now, of course, we haven't inherited this employee type, but we'll fix this right now. So that's it, right? We have implemented this, and what we can do right now is simply override that method. We say public override int calculate salary, and here in this case we can simply take this. Let's take this entire part, and we'll delete the if afterwards. So we don't use the base for the salary calculation, but what we want to do is simply we just return what we need to return. Of course, this is right now not really well formatted, but it doesn't really matter right now. Let's go further. Private class, what was the other? Senior dev. And also this class would inherit the employee type. So we'll create the constructor. In the constructor we get once again the value, the description, and we pass it to the base. Value and description, that should be it. Now we can simply once again override the method public override int calculate salary, and in this case what we want to do is simply use you are here for the senior. Let's only return this, and we just return it. So that should be it. Let's also remove the white space, the white line, and we still have the team leader, and so let's create a private class for this team leader. Private class team lead. This class would also inherit employee type, of course, and then we'll have to just implement the constructor, bring in the value that we need, bring in the description that we need, and then just pass them to the base, of course, and it would be the value and the description. That's it. Let's also here remove the white space, and let's implement or override the method public override int calculate salary, and in this case we return the way we calculate the salary for the team leader, and that's it. Just return it, and then I guess it should be okay. And then for the initial calculate salary method that we have right now, we can just simply return the default 0. So if we have a type that well, we don't actually implement the behavior in the subtype, then for now we just simply return 0. But just in a few minutes we look also to one other way that we can further enhance our custom enumeration classes, and then this method would actually become I would say right now a little obsolete, but for now let's keep it like this. So in this case we just have to remove here for the mid, we just want to create a mid dev. For the senior we just want to create a senior dev, and for the team leader we just want to create a team lead, a new team lead. And once again, that's it. If we go to our program and run it, it would, sorry, of course we have to, sorry, we have to make changes here. because right now what happens is that okay, calculate salary. Of course, the others we have to remove the types that we passed in as parameters. Then we have also to remove the senior. Once again, in this case, we just need to provide the number of worked hours, because the logic on how a salary should be calculated for each type of employee is now logic or behavior that is inherent to the employee type class, or to the subtypes that the program class is not even aware of, and it shouldn't be. This is how object-oriented programming is supposed to work. So right now, if we run once again this program, I guess it should give us the correct results, and yeah, that is correct. Now in this case, once again, just as a summary to what we did so far, is we just enhanced this employee type class. We created subtypes of this class, and each subtype then contains the own logic for how to calculate a salary. So then when we use this in program.cs, based on the junior, the mid, the senior, or the team lead, we will execute the logic that is specific for this type only. And this is really how polymorphism is supposed to work. Now, as said, we can even go one step further and add and think a little bit more about what could happen in a program that we have. And if we run a real program, I would say, not a console application for demo purposes like we have here, what we could do, or we would be in the situation at a certain point that we would need to implement other enumerations. So in that case, we would need to go to each type of enumeration that we need, and create all these things around the custom enumeration. So we would need to create the constructor, we would need to create these properties, to override the Tostring method, and so on. And probably we wouldn't need the calculate salary, because other enumerations might not have this idea of salary calculation. So it could be that some enumerations would need this, but some other enumerations wouldn't need it. So in this case, what we can do is simply create our custom enumeration base class. And let's go and add a new class here, add class. And here we will call this class enumeration. We will make right now this class, it would be public, but it will be abstract. It's a base class, so it should be abstract. And now what we can do here is basically move most of the logic that is common for all enumeration from the employee type to our abstract enumeration class. And here we would have, for instance, we have a constructor. That constructor should be private. And here in this constructor, we would need an int value and string description. What we would need here are also the properties. So public int value get private set. However, this constructor, I would like to make it not public, but protected, so that only types that inherit this enumeration base class would be able to use this constructor. So let's go then also public string description get private set, and of course in the constructor then we assign the values. Description would be equal to description, and that should be it. Now another thing that we can do is simply override the Tostring method, public override string to string, and we will return the description. And this is common behavior for any custom enumeration class that we might have. So when we have this ready, we can then just go back to our employee type and change things just a little bit. Here we can make this class employee type inherit enumeration, and if inherits enumeration, what we can do here is well, we don't need these properties anymore. In the constructor, we don't need to specify to assign these properties, but what we would need to do instead is pass them to the base class, which would be value and description. So that would be it. We can also make this protected. That shouldn't be a problem. Now the Tostring method is also already in the enumeration base class, and what we can do right now in this employee type class is, since we're always using subtypes for the different types of employees, and each subtype would implement then its logic for calculating salary, what we can do here is we can also make this employee type class abstract, and to enforce that each subtype should implement a calculate salary, so we can simply say that this method should be abstract. And of course it is abstract, we don't have to provide the implementation for it, so that should be it. Okay, of course, as it's an abstract class, we don't need this this virtual keyword anymore. But then, of course, all overrides are still there. So right now, I guess we have everything what we need. We have, once again, a base class for what an enumeration should look like. It contains the properties of value and description, and it overrides the Tostring method. We have this employee type, which we now created or made as an abstract class, because we will expose only subtypes that are private classes inside this employee type class. And here we didn't change actually anything from the last modifications of our fields. But what we have changed is that we have turned this calculate salary method into an abstract one. And we did this in order to enforce that all subtypes or all other classes that inherit from employee type would need to implement this behavior, this calculate salary behavior. And right now, if we go back to this program class, I guess nothing should change here. And if we run this once again, it should print the exact same things that we had also previously. Only that right now we have a fully open closed custom enumeration class that we can extend at any time with behavior, and that extension, that added behavior, won't break our existing code base, no matter where this employee type class is used. And that's why I think that custom enumerations are really powerful. But before we end, I just want to add something else. If we take into the consideration this the default enum, so let's in employee type enum, and let's take one of it. And here we have, for instance, we see that on the default enum we have some methods like compare to, equals, get hash code, get type, and so on. Actually, what we could do is implement all these methods on the enumeration class, but or on the enumeration base class. And since it is our own base class for what an enumeration should look like, of course we can add a lot of more default behavior for each enumerations that are not there for the default enums. So basically the options that we have right now at our disposal are, I would say, limitless. So this is how custom enumeration classes work. Right now, I guess this video became fairly long, so I won't go into extending this enumeration base class with behavior that we have seen previously, like implementing a hash code, equality, comparison, and so on. To do that, we would have to implement some interfaces, and there are some best practices there on how to implement, for instance, equality, get hash code, how to implement comparison, and so on. But if you want to see a video on how we can extend this custom enumeration base class, just drop a comment and a like. Let me know that you would like this type of video, because otherwise I really don't want to create a video that won't be useful for anybody. So if I'll see that there is interest to see how we can extend this custom enumeration base class with I would say proper behavior that we could use in production ready code, then just let me know using the comments on YouTube, and of course the like. That would be very, very important. And if you are here and you didn't subscribe already, a subscribe would really help. That would make me feel that this content is really valuable and is important for you. You can expect a lot more videos coming on here. I'm also live streaming on Twitch. In the description of this video, you will also see my Twitch channel. So follow me there for live streaming, because I do some things that I guess might be interesting for some of you, like building a social network from scratch using domain-driven design, or if you are a beginner, or I would say a developer at the beginning of its career, then I also have a stream on how to create an eShop API from scratch, following all the rest principles. So thank you very much for watching. I hope you learned something from this video, and I hope to see you the next time. Have a nice day. Bye.